Hello, I want to spend some time to talk about the even and odd trigonometry function. Now, let's do some recall. The basic even function is the quadratic function. Why is that? Because, take a look, 2 squared equals to 4, and negative 2 squared also equals to 4, right? Similarly, 4 squared equals to 16, negative 4 squared equals to 16. So do we notice something? The pattern. Well, for x squared equals to y, then negative x squared also equals to y. So that means what? Well, if we would write it into a function notation, I have fx equals to y, then f of negative x also equals to y. Together, a equals to b equals to c, that means a equals to c. That's how we got the even function. We just proved that quadratic function is even function. And the quadratic function look like this way, right? Symmetric over the y-axis. Now, take a look at our cosine function. We know how to graph a cosine function. If you don't know how to do, remember it. So one way to do it for me is to memorize the graph. I know that cosine functions start from the 1, go up and down this way. So on the left side of the coordinate plane, it looked like this way, right? So look at the blue and the red. What do they look like? They are symmetric over the y-axis. That means cosine are also odd function. Oh no, sorry, even function. Similar to y equals to x squared. That's the way that I remember. I remember the graph of a cosine function is symmetric over the y-axis, similar to the graph of y equals to x squared, the quadratic function, the parabola. And I know that quadratic function is an even function because we just proved it. So similarly, instead of using the f, we use cosine because f is function. And x, we can use theta. So we would write it fx equals f of negative x. F stands for function. Now it's the cosine function. X is theta and equals to cosine negative theta. That's how I memorize it. Similarly, to the odd function, the most common odd function is the x cube, like 3 cubed equals to 27, right? And negative 3 cubed is equal to negative 27. And we do the same thing for that pattern. This is equal to negative 8. Now, summarize it. If x cubed equals to y, then negative s cubed equals to negative y, right? Again, we write it into the function form. If fx equals to y, then f of negative x equals to negative y. How can we still do this? A equals to b equals to c? Well, I can multiply negative 1 on both sides. So that I get negative fx equals to negative y. And then f of negative x equals to negative y. Now, we have the a equals to b equals to c thing. Then we got f of negative x equals to negative f of x. That's for all the odd function. And the cubed function look like what? One of my students told me that it's the snake. I say this is x, but yeah, if a snake is a snake. So what's special about the snake? The snake is symmetry about the origin. So here is the origin. So that means if I can find a point here, symmetry over the origin, I can find another point in here. That's what they call symmetry over the origin. Now, let's look at our sine function. Sine function, starting with the 0, look like this way, right? Continue. And then on the left side, look like this way. It look like what? There's symmetry over what? The origin. If there's symmetry over the origin, that tells that this is going to be an odd function. That's how I memorize it. Or I can say this is symmetry over the origin, similar to the cubic function, which is an odd function. So an odd function is what? F of negative x equals to negative f of x. Well, instead of f, I write it as sine of negative theta. X is for the numbers, theta is for the angles or the radians. And I have a negative sine theta. That's how I prove it, how I memorize it. It's just by the graph and linked it to the graph, that's something that I learned before. Now, tangent. Tangent, let's prove it. Tangent negative x is equals to sine negative x over cosine negative x. And we know that sine negative x is equals to negative sine x. It's an odd function. And cosine negative x is equals to cosine x. One positive, one negative give us a negative. I can pull the negative out. So I got negative sine x over cosine x. And this is tangent x. So together, this is an odd function because tangent negative x equals to negative tangent x or theta or y, whatever that variable that you want to use, that's okay. So to memorize tangent, you don't need to memorize the whole thing, how you come from here to there. I just remember that a positive number times a negative number gives you a negative number. So that's why you end up to have a negative number, negative tangent x. And the rest is secant, cosecant. Oh, sorry. So cosecant is equal to 1 over sine theta, and the secant is equal to 1 over cosine. Tangent is equal to 1 over cotangent is equal to 1 over tangent. So if this is a odd function, so that means cosecant also an odd function. Cosine is an even function, so that means secant also an even function. Tangent is an odd function, that means cotangent will be an odd function. That's how I memorize all of them. Okay, I'll see you in the next video.